Hi, my name is Evan Schwartz, and we're going to be looking at weeks 3 and 4 projects across a myriad of devices. This game is called VoiceFuel, and it is testing both the magnetometer and the recording capability of the phone, and it uses audio to act as fuel. So I'll go ahead and get it started. We'll go through the menu on the first one here. This is an iPhone, so how to play. Goes through, you're going to start by tapping the fuel button, use your voice to fuel up your ship, tap your ship to thrust, capture asteroids for score, level ends when fuel is gone. That's just that simple. This is the credits, basically me and where I got all my stuff. So let's get to it. Alright, so you've got score, level, and target. That's your ship. These are the asteroids bouncing around in the arena. This is your angle, as you'll see the ship turns as I'm pivoting, so I'm not sure if it's going to be super easy to see, but I'm going to go ahead and fuel up my ship. This is a fuel test. So what it does is you press the button and it records your audio, and then it analyzes the audio file, and based on various peaks and valleys it presents a fuel point, and you get so many fuel points for doing different types of audio. So I'm going to pivot, and I'm just going to touch and use up one of my fuels. Not sure how easy that is to see, but we'll have a screencast of this. It'll make it easier to follow. I missed, but I got one. And the goal is to try to get your target level. So I've got 2 more to get. If I can spin around, I can get him. So I've got 1 more. If I get 1 more, then it goes to the next level. Did that. And on the next level, you get to fuel up again. Buckaroo Banzai.
Buckaroo Banzai?
It doesn't like Buckaroo Banzai. I only got 6 on that one. Alright, so we'll push through. And I'll go ahead and burn through my fuel. And game over. And that's my score. Alright, so that's the iPhone. We'll shift over to the iPad. Or no, this is going to be an Android tablet, sorry. And we've got the same VoiceFuel icon, so I'll go ahead and get it started. We use Corona Labs this project. Same things, going through just to show a slightly different size device. Begin the game.
Begin the game.
And you pivot, and you launch and collect your guys, and hopefully you don't run out of fuel. Game over. And we'll look at 2 more. We'll look at the iPad Pro. This is a big boy here. Go offside to open it up. And we've got our icon there. Just showing different size screens. This is a recording as long as I can make it, blah, 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 blah.
This is a recording as long as I can make it, blah, blah, blah.
Got 8 points on that. And then you play your game. It's a little more cumbersome with the giant iPad Pro, but you get the point. And I won. Hey, level 2. Alright, and then you can exit out any time on that. The last one we're going to look at is the Nvidia Shield. That actually came with a lunchbox, and I've been having some problems. So I'm showing this one because I can't get the audio to work on this one. All the other mechanics work fine. And you can pivot your ship fine, and it reads the magnetometer. When this is plugged into the port and we're looking at the Corona debug output, the only clue I get is it says it can't load the audio file. So this is just a test of the audio file. Essentially after the 3-second record time, it just sits there. I've been unsuccessful in figuring out why the K1 Nvidia tablet does not work. Okay, let's take a look at the code and dig in from there, and then we'll show a screencast. Thank you.
Hello, my name is Evan Schwartz. We're going to take a look at the code behind VoiceFuel. So let me get the project up. We built this in Corona Labs, and my primary decision for using them is I didn't know about them, to be honest with you, and I've never coded in Lua script, so I wanted to be able to do that. So let me just get the environment set up here real quick, get to the code, and we'll grab the main Lua. We'll get all the little project files up and going. Okay, so one of the things to realize, and I'll hold the emulator out here so we can kind of get a frame of reference. You've got your main Lua file, and this is pretty much given to you when you build it out. What this does is we're setting up a composer. That's Corona Labs' way of going through scenes. Each scene is well compartmentalized in its own Lua script, its own code file. This just sort of hides the status bar at the top if you've got one. I know some of the Androids have that. This sets up your random seed. A lot of programming languages need you to kind of initialize the random seed. This sets up your physics and your gravity. Since I'm doing kind of a spacey game, I need my gravity to be 0 in both directions. It's a 2D based engine, so X and Y. Gravity's not pulling me in a different direction. Lua doesn't really have complex structures. They have things called tables. Looks a lot like JSON script. So this is just options in a table format. This is how they do their table format, passed into the composer to go to the menu screen. So this kind of kickstarts the game, sets it up for me, and then sends it to the menu screen. So we'll go. This is the menu screen that we're looking at here in the emulator right now. So once again, this is kind of stuff just given to us as example scene files. Here's my option for fading, set up my composer object. I've got some methods here, go to game, go to credits, go to how to. Everything below here is the standard life cycle for a scene. So there's the create, the, sorry, I get flipping between the Windows and the Mac, I get messed up on which direction my wheel is going. So I get the show event, I get the hide event, and the destroy event, and it loads all these up as event listeners. So there's a lot of eccentricities for Corona Labs, and the most of which is that it seems like all these variables never go away. So you have to put them into a scene management. So you put them into a scene group. That way you can control whether you want that group to hide, go away, show that stuff. Otherwise, once you put it on the screen for one scene and go to another screen, it sits there as an artifact. So it was very interesting to get kind of over the concept that as I move from one scene to the next, that it's kind of like in Unity where you keep everything alive from one scene to the next. So it's a little bit challenging. Back here, I'm loading up my background, setting it into my scene group so that I can make it go away and fade as I go from scene to scene. And these little text doohickeys here, these are the equivalent. Here's my voice fuel and setting up. And then this is how you wire up your on clicks. So it's called a tap. And for my game text, which is the play button, is go to game, and that comes up in here, and go to game, it just goes to my level 1 scene, which really is where all the interesting stuff is. But if I come over here and I click on that, you'll see it fade and go to the credit screen, return menu, how to play, return to main menu. So if I jump over to those real quick, here's my credits, shockingly similar, setup and comparison. I've got to go to my menu just to go back, and this is an interesting little thing where I can ask the composer where I came from, and I can get its name and go back that way without having to hard code it. And then the rest is just put my background and it's on the screen and set up all my text objects and put their coding there and what we want them to say in their output. This is just all their basic layout on the screen parameters, nothing complicated. Set up my event listener for the return to main menu, put everything back in the scene group so that everything fades properly or as it should be. Okay. Same thing on the how-to. Pretty much the same stuff. Setup, composer. Here's a button to go back. Here's my background. And then here's all my little text strings and maintaining everything in my scene group. So the interesting stuff here happens in my level 1. So it's a big long script, so we'll dig through it one piece at a time. This has my sprites on it. I created a sprite sheet. Well, I didn't create this. I pulled this from one of their demos. They had a nice little sprite sheet that laid out. So I'm using their asteroid and spaceship at this point. But again, as you can see, it has a very JSON type feel, where I'm doing nested table structures, as they call it, nested arrays, however you want to look at it. So I've got my options, got my composer, got my scene stuff. These are just my sheet options that show how to cut and pull out my graphics on my single sheet, get all my sprites out of there, my scene group. These are all my initialized variables. So these are all my game variables: fuel, score, level, target, asteroid count, all of that stuff. This is just setting up my display groups. So I got a little bit smarter as I got to the level of putting things into their own display groups so that I can layer them properly and I can move them front and back. Rather than having to touch every single component on the screen, I can just say, okay, hey, take this entire group and move it back. So that's a nice little layering functionality. Didn't end up needing it in the beginning as I was playing around. I thought I was, but still good practice to do. These are some helper functions. Am I fueling? What's the file name, path? This is all for my audio mechanic. So this is the big piece here that I'm wanting to be able to record something. Then I go in and analyze the voice recording, and then you get rewarded for fuel. And this is a prototype for the capstone game Battle Cry that Nick asked for. So ultimately, it's the same type of thing: recording audio, processing the audio, and you get some sort of value out of it. This is my background music, the crash sound, the thrush sound. This holds my magnetometer. So the other key mechanic in VoiceFuel is the magnetometer. As you're spinning the phone, it's detecting a magnetic field in this, similar to a compass like true north. You can on the Android, you can actually mess it up really easily with a real magnet. So I found that easier when I had the cord plugged in to just grab a magnet and move it around the phone rather than trying to spin the phone. I guess that's a way you could cheat. So here's my update text. So this sort of updates my HUD, very basic function. This is my X button on the play to be able to go back to my menu. So we'll go ahead and have this running in the background so you can kind of see where we're at. I don't know, that sound might be a little bit difficult to deal with here. But that's this button here. So we'll go ahead and go back. Game over. This is basically a helper function that says, hey, if the game's over, let's clear out our asteroids, get them out of the table, get them off the screen. We've got a gamer loop that I'm keeping up with various actions in the game as it's moving around. We want to kill that timer. We want to stop the background music because I only have the background music playing during live action in the game. And I'm setting up a variable so I can pass to my game over screen. That's probably the only other interesting part in the game over is that it's grabbing the score from a composer variable and updating the score text so that way when you lose you know what your score is. So I've got several fueling methods, so we're going to start at the beginning because it's easier to follow. So we start with get fuel, and I'll just come back over here real quick. As you play this, and hello, I'm starting with fuel, blah 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 blah, let it record. So, and I got a value of 9. So that's basically the mechanic in action. So on get fuel, we basically, once you tap that, we want to hide all this stuff, right? We don't want you to keep getting fuel. I need to stop the background music, otherwise that ends up coming through in the recording and messing up my baseline formula. I set up a path to where I'm going to record the media file for or at, and I begin my recording. I want to get my sampling rate, and I want to set my sampling rate. So I'm setting it here to 8,000 samples per second just to create as small a file as possible, but still have meaningful audio coming out of it. And then we start recording, and then I set up a timer that performs with delay that says, hey, after 3 seconds, stop it. Right, so that you've got 3 seconds to do your recording. So this runs, and then you exit out, and then you're kind of in an event-driven 3-second clamp. So it's recording everything for 3 seconds. So this is the method that runs after 3 seconds. So it stops the recording, sets the R to null, and at that point my file has been created, right? So I don't need the R anymore. And I create an audio channel, and I load my file up and I want to play it to the player. I want the player to see or hear what was just recorded, so they know that it's actually doing something. Right, that just is a feel-good thing. And anyway, at the end, this has a timer that says on complete, do the done fueling. So after I'm done playing it, at that point, the file is being grabbed by the file system and streaming it into the load player. I come here and I need to stop it, clear it, dispose it. This just guarantees that then nothing is still got a handle on my audio file, because now I need to go in and process it, and that's what this little method does. So then I basically come down and I set up a file open string. I need to get access to my file. I have a test rate and a byte size. I found that Android and the iOS system are very, very different because they support different file formats. So the state of those values. Now in this algorithm, this one isn't nearly as complicated as the algorithm I want to use in the capstone. So this is really just doing a byte by byte analysis of the audio file. And if it can't get it, it just says file error and then outputs the error string. Had a problem with my Nvidia Android Shield tablet. For some reason, can never seem to get the file back. It creates it. I dug in, I rooted the thing, I looked at it, I could see the friggin' file, but it won't access the file loaded, or it doesn't support the format. Not really sure what's going on. I tried a variety of different sampling rates to try to get it to work, and I just couldn't get it to work on that one. But I got it to work on my other Android environment. So at this point, I start to read in one byte at a time. That's what that's doing into my contents. I'm grabbing my previous byte. So what I'm doing is I'm going through the file, I'm making assumptions about this byte versus the previous byte. And then I have my test rates, my sampling rates that I'm comparing them against. And if my previous byte subtracted from my current byte is greater than my test rate, then you're going to get a bump in fuel. And then I store the previous byte, and I just iterate over these with this really, really simple formula. And I'm just taking the absolute value of these two items. And then at that point, that gives you a certain number of fuel to play with. And I've gotten as high as 24 fuel units on one type of scream into the phone, or a variety of words I've gotten as low as 4. And if you're in a completely quiet room, it's basically 0. All right, so then it continues to read that file until it's done, upping the amount of fuel, and then at that point it does some calculations based on remainders. So it's trying to get to the remainder based on 1,000. So as you can imagine, at 8,000 samples per second, and I'm running for 3 seconds, I'm gonna have 24,000 bytes in an 8-byte audio format that I trigger through. So at that point, I divide that by 1,000 to get a more reasonable number out of it. This is my control, so as you'll notice that if you're just sitting in the game, we'll come back to it, and I don't have any fuel, and I'm just playing around, I can bump off of them, but I can't collect them yet, right? So this is sort of the trigger that tells me whether or not I'm in collection mode or not. I want to turn my background music back on, I want to update my HUD, and then I need to close my file. At this point, I set the file to null result, and then I go ahead and remove the file. I'm done with it to clean it up out of the system, and then I output fueled up. Now these two outputs are only visible in this output log when it's connected for a debugger. Very helpful to me though, explaining why I can't get it done. So that's basically the bulk of the main mechanic for audio. We have our create asteroid function. So this is called in the game loop, and is just keeping a look at of how many asteroids are currently in play, how many do you need to get, and as long as you've got less than 2 times your target, that's pretty good. We don't want to fill up the entire game board with asteroids. And then it just goes through the asteroid creation, which is just a new image rect, grabbing from the main group, my object sheet. I dictate where on my object sheet I'm grabbing that asteroid, puts it into this variable. It's a loosely typed language. Not a big fan of that on the as far as the Corona framework is concerned, in my personal opinion. I add the asteroid that was just created to my asteroid table so that I can keep a track of it, so I can clean them all up as needed. I make sure that it has the appropriate physics body added to it, and I give it a name so that I can easily reference it, and then I give it a scale. I've scaled it way down. It's really much, much bigger than what you see in the game. From here, I have just a simple fly in from the left, fly in from the right, fly in from the top type of algorithm that is getting the asteroids to come in from different directions. Makes it look a little more dynamic as you're playing. See, that one came over that side. These two, a bunch of them come over from this side. This one came in from the top. That one came in from the top. So that's really what that little routine does. And then I apply some torque to it just to get them to spin. It's a random amount of torque. Just to, again, this is all more just aesthetics to make it look a little bit interesting. This method is my thrust ship, so this essentially will push the ship if I have fuel, so it manages the reduction in fuel. It plays the thrusting sound. Because the ship is rotating, I need to do a little bit of math here to find out exactly where my ship is pointing so that I can get a general linear velocity associated with that. So I've got a little subfunction in here that will calculate my velocity. Just some very basic math on taking your radians and your angles and figuring out that you're moving in that direction. What should my velocity be? And at that point, your ship's linear velocity is you take the linear velocity and then you apply an impulse against it. So it's pretty simple stuff. All right, this is my start level. So this sort of kickstarts everything, and as you progress from level to level to level, this will pass in level +1. This keeps the score going from level to level. But this allows me to sort of start the level, so it sets all my visibilities and everything I need back up, sets all my Boolean switches back, sets my fuel, and it controls my targeting. So if I had a test script sitting on this, I'd make sure that, hey, my target must be level +5, and if it's not, it's a problem, right? Sets up my counters. I had started off having where the player could die, but that ended up going away. So that's just some cleanup that needs to happen, and then an update to the HUD. This is the game loop, so I'm always calling create asteroid, as we saw in there. It's sort of self-licking. It'll make sure it's not creating too many asteroids, so I can just keep calling it. It's no big deal. This goes through and looks at each one of the asteroids. If for some reason they escaped my walls, it's like anything else I've seen in many game engines. If you've got too much velocity or I've bounced into something and knocked it, it can get past a collision detection, in which case it flies off into space and it's gone, and then that kind of messes up my create asteroid because it thinks it's there but it's not on the playing field. So this is just sort of a catch-all to make sure that, hey, if it shoots past my wall and, the collision doesn't catch it, just delete it. Don't let it get too far outside and just destroy it, and then we'll create a new one and put it back in the playing field. So this is just really mitigating code for anything, lack of a better term. All right, did I beat the level? So is my target less than or equal to 0 and I'm in level began, which means the game's still going on? If so, I need to go ahead and let's clear out all the asteroids that are there. Let's set my level to next one. Let's give you some score. This is extra points if you have fuel left, right? So this is my bonus scoring system. You're collecting scores as you go, and then I call my start level to start the next level, and it kickstarts the whole thing. If your fuel drops below less than or equal to 0 and you're currently playing, then you're game over. It's time to go. So what this may need a little bit more tweaking. I've determined that I guess it depends on where it is in the game loop, but more often than not, as I'm hitting my last fuel and thrusting, fuel goes to 0, still in the game, didn't hit my target, and the game's going into a game over state, even though I would have bumped into the last one. So yeah, maybe put a timer in here. Yeah, I'm in 0 fuel, but let's give it maybe a 2 or 3 second float time. That might have been an interesting thing to do, and I may come back to that and do that. This is an event, so what this is doing is this is capturing the magnetometer for my ship and basically getting the event's magnetic reading. I'm adding 90 to it because of the way I want to rotate it. So this is just something I added to get that rotation to look right on the ship because I'm holding it, face down with the player button down here, and I wanted you to be oriented up at 0, so I'm adding 90 to it. And then I set the ship's rotation to my magnetic, and the reason I'm storing it in this variable is so that my HUD can update it so we can see the magnetometer output at the bottom of the screen. This is my collision detector, so this is the begin collision, and as we go through, make sure that the level is in fact began. So you'll notice as I'm playing, you can have asteroids bounce off of you, and you just bounce around, and nothing really happens in the collision guy, but physics is still going on, right? So we'll see if these guys hit. Yeah, see, so that's a collision detection. Something's happening, but we don't want to do anything interesting in the game until the levels began, in which case you have to have fuel. So this is capturing, object 1, object 2, what was collided. I had some laser beams in there. I left this stuff in there in case I come back and wanted to put it back where you could blow up the lasers too in case things got out of control. But ultimately, I just wanted you to bump into them and collect them. So this doesn't really do anything anymore. But in here, it checks to make sure if you're the ship and the asteroid between the objects, play a crash sound, and up your score, decrement your target, and then find out which one of the asteroids you hit and remove them from the table, and then update the text. Then below here, we're back into, we do have one more function, our create walls. So this is just, it was becoming a little bit crowded here in my create method, so I pulled out the wall creation side and just made it more programmatic to be able to spin up the walls. The walls, you can't see them, they're back behind, they're white. You can see them on the iPad Pro, I guess because of the weird dimensions, but everywhere else you see my graphics sitting on top of them. But this was a first attempt by me to stop my asteroids from being bounced out of my arena and overrunning my collision. So I made some really thick walls. So I don't see it as often, but I left all the mitigating code in there just in case I do happen to get through one of the randoms. One of my asteroids are so fast that it overrides my collision. So I built this little routine to be able to kick out bigger, thicker walls, but they're out of sight. So below that, then we get into our life cycle scene for each one of the scenes. So the create, and this is setting up my scene group. This is setting up my basic platform names as to whether or not I'm using this to make sure it's Android because I have to flip the file name. This is the only thing I really don't like about the audio between Android. This works really well at multiple sampling rates. This doesn't. For some reason, like I said, I'm getting inconsistent results based on the Android that I'm running it on. I only have 2 here at my disposal. One it works like a champ, one it doesn't work, so 50% average is not a really good average. This is pulling in my object sheet for my sprite. This is then loading up my background, my star field, and setting this is creating all my walls, and this is putting my background into my scene groups so that it can fade in and out appropriately. This is basically getting the my various platforms. So this is my graphics sitting on top of the wall. So you don't just see this obtrusive, Pong style white wall that these things create up here. So these are just all my graphics for the walls, and I create each one and scale it and grow it to make it look like a contained area. And I thought that looked a little bit better. So this is a platform right, left, top, and bottom. This is my gas pump button, and it shows up at the beginning so that you can press it and do your fueling up. This sets up and creates your ship and gets it ready to play. Again, still adding everything into my scene group. And this is setting up my background music, my crash, and my thrust audios. This is setting up all my audio channels. So if I had everything playing on the same channel, they would be overplaying each other. So it would immediately stop the first one and then play the new audio channel again. And so I'm breaking out the recording onto its own channel, the background to its own channel, and the crash and thrust to its own channels. Thus, I'm using 4 of the 32 channel limit that Corona Labs has. This is sort of this is a helper function to lay out my HUD as it's going through. So you'll see I'm adding this left push. So that this is just a convenience item. As I was trying to get everything to set up on the screen, I could just control one variable and it moved everything around. I laid everything out relative to every other thing, and then I wanted to be able to move the whole group. So that just made that really easy to do that. And this is sort of outputting my sensors so that I can keep a look at where I am on the angle perspective. Everything gets added into the group that hasn't been so far. I set up all of my event listeners, so I have my tapped thrust, my collisions, and my heading. So I originally had my thrust tap on my ship, but moving the device around and trying to touch just your ship was way too complicated. So you can move the device around and tap anywhere on the screen. This is adding event listeners at the runtime level, but you can do the same thing for any object. So as you can see here, here's edit text, add event listener, tap, and that sort of thing. Then below that, it's just the show. This becomes real simple as I come back into it. I set up my game loop, start level, and I begin my music play. So, as an overall experience, I like LuaScript. It's really, I guess, concise. It lacks a lot of the strong typing that I'm more accustomed to. As far as an overall framework, I'm continuously surprised at how quickly you can spin this stuff up. One of the things I do like about the Corona Lab framework is that they use a build server, rather than having to have your entire environment fully set up with, the Xcode and the Android Studios and all this stuff that you have to build. But it does give them a lot more control over your output. I had another framework I used, Game Salad, that was very similar to that. You didn't really have to have anything. You could push it up there until it would target a framework, and it would spit out APK or whatever it is you needed for whatever targeted platform you were shooting for. But again, at that point, you're kind of relegating that control to that framework. It gets you in the door a little bit faster, but I think long term it limits what you can do with your own product at the end of the day. Liked the experience. Not a huge fan of LuaScript. I think it's too loosely typed. It's real hard to. You have to really enforce your own structures to it. Um, Being able just to create variables on the fly, I was just never a fan of that. So at the end of the day, I'm still very much in love with Unity. It creates a more consistent product. When you're said and done across all of the platforms. So what you see, what you build is closer to what you get on an Android, on an iOS, on even Windows, on Mac. It's closer to what I expect in the experience that I designed without having to go in and wrench things down. And I mean, Unity has its own eccentricities as well, but it's just feels like a more superior, more mature product. And this has been out for quite a while. Corona Labs has been around for a while, so I would have expected to see a little bit more wire up than what it is. It feels still kind of clunky. I'm using a free coding thing that doesn't feel very well intertwined, even though Unity uses something similar. There's a lot of help files, there's a lot of code completion. Getting all that wired up for Lua was actually, it didn't work. At the end of the day, I couldn't get it wired up. It blew out the entire thing, had to scrap it and reinstall. So this was tantamount to coding with Notepad. To put it in perspective, there was no code completion for me. Case sensitive methods and things were a constant battle as I was putting this bad boy together. But it was still an eye-opening experience to see across all these platforms how similar their approach is and how they attack some problems from different angles. I really like in Corona Labs how they use the transition to, how they just allow you to set properties and the things behave. They have a behavior, and then you work with that behavior. So you're not really controlling. You lose sense of the game click, right? What I mean by that is that game loop that I built that so I could have more control over the game loop. Because in Lua or in Corona Labs, you just don't, right? You give all these properties, and then the whole game sort of takes on a life of its own. So you're mitigating events that are happening in the game to you, right? As opposed to trying to control what is being seen. I have a lot less control over those asteroids once I put them on the board and set them loose. They're just doing all that, right? So it's a very different mental approach to the design. Anyway, that's Voice Fuel. I hope you enjoyed it, and look forward to the next one.